Hello at our section number 4, Exploring the Local System Security. In this section we will take a look at how to secure the local Linux operating system. This contains securing the boot process, dynamic kernel configuration, understanding the suite and SJIT functionality, and using permissions to secure the local file system. Before we start into this, I have some bad news. If an attacker is able to compromise the systems and gain local access, not as root user but maybe some unprivileged user, still it's only a matter of time until he obtains full privileges. So there's lots of things you can do to secure the local file system and all the things. However, chances are high he will still make it. Why is it that a local attacker has so much better chances for a full system compromise? If you remember the first section, we talked about the attack surface. A remote attacker can only attack the remote network services, like SMTP, HTTP, etc., like we had in our example. A local attacker has a much wider attack surface. He can attack directly the Linux kernel, like IOCTL, syscalls, the file systems, Bluetooth, Wi-Fi, USB, PCI if he's local. Additionally, he can attack the local network services, which are not reachable from remote. Maybe POP3, MySQL daemon, DNS daemon, Graylist daemon, and maybe others. Plus, he has access to the file system, so he can attack suite files, SJIT files, maybe read permissions to sensitive data, maybe write permissions to sensitive data, and attack programs which insecurely work in temp. Because of this, it's really hard to protect a system against a local attacker. That's why for this training, I will keep things very brief. We're now talking about securing the boot process. In this video, I will show you how to secure the boot up process of Linux. I will now show you what an attacker can do if he has access to the system locally. We are now at the Group Boot menu. This is the menu you see when you boot up Linux. To be able to show you this, I have to do this in a virtual machine. Otherwise, I would not be able to record this. An attacker who is local, he can boot up the machine and see this menu. In this menu, you can select boot options and, for example, press E for edit. He scrolls down to the Linux kernel configuration and adds another parameter. Press Ctrl X to boot and gained full system access as root. What happened here? An attacker modified how the Linux kernel initializes the system to call a root shell the attacker can then use. This is, of course, something you need to prevent if you want to secure your system against local attackers. To be able to perform the attack I just showed you, the attacker must be local, so have access to keyboard and monitor. However, especially in data centers, servers are usually configured to have a console, a serial console attached to a terminal server. If an attacker is able to compromise that, he can even perform that attack from remote. How do we prevent this attack? The bootloader we just saw, this is grub, which is the default bootloader in every Linux operating system now. Prevent this attack. First, we create a secure password hash. Then, edit the configuration of grub to use this authentication. Then we generate a new configuration. I will now show you how to do this in detail. We're on the Linux command prompt as the user root. First, we create the password hash. The command is grub-mkpasswd-pbkeyday-f2. We enter our password. For this example, I'll select a very easy one. and we see a password hash being printed. This we have to copy-paste. Next step, we edit the group configuration. On all Linux distributions, this is a special file in etc groupd 40_custom. In this file, we go to the bottom and we append a few lines. Next, we enter the password hash we copied, with the username root in front of it. Then we save the file. After we've written now our configuration, we have to write a new group config based on our customizations. Depending on your Linux distribution, this is either group-update or update-group. After this, we reboot to verify our configuration, so we are sure it's working. I try again to edit the group configuration from here as an attacker to try to gain access to the system. Now it asks for the username, and if I put not in the right password, I don't get access. Only if you know the correct password, you can still edit the configuration as it should be. Another thing we can do to secure the kernel is configuring sysctl configurations. This is dynamic kernel configuration options we have. I already showed you some of these options in the previous section. Here, these are another options you can set for local system configuration hardening, where you protect hard links, symlinks, messages from the kernel, pointers into the kernel, randomizing the address space, making execute files not dumpable, and disabling the sysrequest key. If you're curious about what do they actually do, just copy the names to the linux.org search interface and you can read it right up there.